Okay, today we're going to discuss about graphing linear equations into variables. And by graphing into variables, what we are talking about is, so if we have the Cartesian coordinate system, you know this is your y-axis and this one is your x-axis, and it has four quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, anti-clockwise. And we all know in quadrant 1, all the values of x are positive, and all the values of y are also positive. So we have x and y. Okay. And if we move to quadrant 2, you know all the values of x would be negative. So negative x, y, and the value of y remains positive. It's in quadrant 3 where you see both x and y are negative. And then in quadrant 4, x stays positive, okay, and whereas y becomes negative. So this is what we call the ordered pair. So the value of x comes first, the value of y comes second. So we're going to do some graphing having this concept in mind. And I'm going to start with an equation. So let's say you are asked to graph 2x plus 3y is equal to 6. So you have two values. One is x and one is y. The easiest ones to use in ordered pairs are the x-intercepts and the y-intercepts. These are the easiest ordered pairs that we can use in order to sketch a graph. The x-intercept comes when y is equal to 0. So x-intercept means you have a value of x, you plug a value of x, and you get the value of y would be 0. And whereas the y-intercept is 0 and 1. Mind you, these two lines rest in the axis. That's why they become the easiest one to draw the graph. So let's find out what 2x plus 3y is equal to 6 looks like in a Cartesian coordinate system. So what I would say would be, first let me find the x-intercept. Okay, so I would say, let y is equal to 0. And if y is 0, the entire 3y also becomes 0. So what you're left with is 2x is equal to 6. And then solve that. If you divide both sides by 2, x is equal to 3. So one of the ordered pairs that you are going to use for sketching the graph is 3 and 0, meaning what? When x is 3, y is 0. Now let's do for the y-intercept. For the y-intercept, you put let x is equal to 0. If you let x is equal to 0, the entire 2x also becomes 0. Then you have 3y is equal to 6, which leads us to y is equal to 2. So you have 0 and 2 as well as your y-intercept. So we have the ordered pairs 3 and 0, 0 and 2. Now let's draw a sketch. And let's see what this graph looks like. When x is 3, y is 0 means, you know, x is a positive. So let's plug it here, 3 and 0. And 0 and 2 means what? So the value of y becomes positive. It is on the y-axis. So this is your 0 and 2. And you go ahead and connect these two pair of points, and you have the graph of 2x plus 3y is equal to 6. So it's pretty much straightforward. So meaning what? Go find your intercepts and then plot the points. Okay, so let me do another one. So suppose you have 4x minus y is equal to negative 3. Yeah. Now again, say let x is equal to 0, right? If x is 0, 4x is also 0. So you end up with minus y is equal to minus 3. Multiply or divide both sides by a negative 1. Then you have y is equal to 3. So 0 and 3 is your y-intercept. Then go ahead, say let y is equal to 0. And then you end up with 4x is equal to negative 3. Then x is equal to negative 3 over 4. So you have negative 3 over 4 and 0 and 0 and 3. Now you can go to your coordinate system. Go ahead and plot where x is 0 and 3 is somewhere here. Negative 3 over 4 and 0, x is a negative number, so it is in quadrant 2. So we can put in here negative 3, 4, and 0, and 0 and 3. Once again, connect these 2 points. And this is a graph of 4x minus y is equal to negative 3. So it's pretty much straightforward. Okay, but there are other instances where you cannot use the intercepts. Meaning what? You have to choose other ordered pairs instead of the intercepts. And that is not also that difficult. So one example is x plus 2y is equal to 0. Mind you, if you were looking to find the x-intercept, you're going to get stuck, because if let x is equal to 0, then 2y is 0. If 2y is 0, y is equal to 0. So both the x and the y-intercepts are just one point. So if you let y is equal to 0, you also end up with 0 and 0. So you're not going to get two ordered pairs. So put a table x, y. You know when x is 0, y is 0. Now let's use two ordered pairs. I suggest that you do one value of x which is positive and the other value which is negative. So let's say x is 1. Let's say x is 2. Put 2 and negative 2. You can choose any arbitrary value of x, but I suggest one positive and one negative because it clearly will show you the direction of the graph. So if x is 2, you're going to write 2 plus 2y is equal to 0. And if 2 plus 2y is equal to 0, then 2y is equal to negative 2 because you are moving 2 to the other side. And your value of y becomes negative 1. So when x is 2, y is negative 1. What happens when x is negative 2? So you have negative 2 plus 2y is equal to 0. Here you get what? Then if that is the case, 2y is 2, right? Moving negative 2 to the other side. and y is equal to 1. So you have 2, -1, and -21. This suffices for us to draw the graph, to sketch the graph. Once again, let's have the Cartesian coordinate system. And you have 0 and 0 here. You know, when x is 2, y is -1, so probably let me put it here, right? When x is -2, y is 1, so this is your 2 and -1, and this is your -2 and 1, and this is your 0 and 0. Now your graph would look like, okay? So if you can't plot using the intercepts, so you need to come up with any arbitrary ordered pair, okay? And by plugging it in, then you'll be able to draw the graph. Okay. There are other instances where I'm going to look at. You might be asked to find graph y is equal to 2. When you see this, the value of x is any number between -infinity and infinity, whereas the value of y stays the same. 2 becomes the constant. So if I draw a graph, what does this look like, xy? So it is -5 is 2, -4 is 2, -3 is 2, and if x is 0, y is also 2. If 3, it is 2. Meaning what? You can have all values of x between -infinity and +infinity, but the value of y remains constant. And that is easy to draw. If that is the case, all you do is what? Find where the value of y is equal to 2. So it is somewhere here. And you know 0 is 2, -3 is 2, -4 is 2. So if you really put the points, so the points are always horizontal. So the graph of y is equal to 2 is the horizontal line. In fact, we might as well define this in general. Y is equal to A is a horizontal line. A line crossing A. That's it. Now, let's look what about if you have x is equal to 3. Again, it's telling me what? All values of y are from -infinity to infinity. So meaning what? X is equal to 3, and -3, 3, -2, 3, -1, 3, 0, 3, 1, and it goes on forever. So all you are looking for is, but the value of x, the constant number stays the same. X is equal to 3 is somewhere around here. So it's going to be, let me put this. This is your x is equal to -3. So x, if you only have the constant value that corresponds to x, then you are dealing with a vertical line. In other words, we are going to define this. X is equal to B is a vertical line crossing B at all points. In fact, let me write at all points. Okay, so that is what we mean graphing linear equations into variables. Okay,